And Helen Snedden, his wife, is the one who set aside the legacy that endowed the chair and has made for this amazing history of lectures. Charles Mason, the chair of the Communication and Journalism Department, is the one who first approached her with the idea about the gift. And there was a lot of discussion back and forth about what form it should take, and she was very worried that UAA might somehow try to take it. And so the Snedden chair is anchored in Fairbanks, and if it was to be anything other than its dedicated purpose of journalism, it would go to other forms of scholarships, again, to keep it here as part of what Virginia Farmier, the business, who account for nearly 20 Pulitzer Prize prizes. Several of them won as many as 3. And we've had just an array of guests in every sort of specialty in journalism that you can imagine. With the Snedden chairs itself, we've had 13 different individual Snedden chairs. Here for a total of 15 academic years, because Richard Murphy sneaked back in twice. And it's just really been an amazing, rewarding thing for the faculty and the students, because nearly every Snedden chair, whether the chairs, but also the visitors themselves, form a connection with, 1 or 2 students that is really deep. And I think J.R. Anchetta, a photographer and a former journalism graduate, as you know, he had his life changed by his encounters with Cheryl Hatch, who was one of the Snedden chairs. So it's really been a program that's had a lot of impacts in many different ways. Tonight's guest, tonight's current member of our faculty, Lois Parshley, is, she likes to say, a well-traveled journalist. She is 8th generation Oregonian, which for people that in Alaska here, we pay attention to lineage, a lot, and who really comes from here and who comes from there. And I'm the interloper from the East Coast that married the distant relative of Aleut Girl. And she's been published in the New Yorker, Harper's, Atlantic, the New Republic, Virginia Quarterly Review, National Geographic, Newsweek, Outside, Wired, The Washington Post, Pacific Standard, among others, and City Paper, where I once worked. So I'm impressed. Anyway, she's got fellowships and awards from the Bread Loaf Writers Conference, a National Geographic Explorers Grant. She's been recognized by investigative reporters and editors, an organization that I feel was very instrumental in shaping my own career. She's a Woods Hole Oceanographic Institution program participant, and won the Knight Wallace Journalism Fellowship at the University of Michigan. And the thing that I think is most just incredible in terms of the range and the things that she's covered, and you'll hear a lot about those sort of things tonight, is she is the first Snedden, I believe, that can stake the claim of she is reported from all 7 continents. And I think that's something this audience in particular would appreciate. And with that, I will give you Lois Parshley, our Snedden.
Thank you, Brian, for that excellent introduction. I certainly can't live up to it. And actually, one of the things I'm going to do tonight, hopefully, is to talk to you not just about successes, but about failures, because I think that's something that's important, too. I am really thrilled to be here. It is a wonderful opportunity to be in Alaska, and one that I have spent many years dreaming of. So for me to be here this year is just a dream come true. Great. So you might not have noticed, but the weight of the world recently changed. In a suburb of Paris is a vault where behind several locks and an airtight vacuum is a small, shiny cylinder that until recently determined the mass of everything. Until last May, this chunk of metal was the definition of a kilogram. It's called, rather poetically, Le Grand K. Forgive my French pronunciations here. For the last 129 years, whether you're in Morocco or Maryland, that was the mass of a kilogram. But since it was created, the metal cylinders lost about 50 micrograms, which is about as much as an eyelash. When it changed, so did all of our measurements of mass. If it were scratched or collected some dust, the definition of a kilogram had to change also. On a cold winter day, I sat down in Paris with Richard Davis, a physicist at the International Bureau of Weights and Measures, who explained that while other basic definitions of measurements had been updated for the 21st century, the kilogram was the final holdout. It was the only basic unit that was still defined by a physical thing. Today, we take for granted the idea that a measurement, like a foot or a gram, means the same thing everywhere. But when the Bureau was invented, this was actually a really novel idea. During the French Revolution, as democratic politics gained popularity, scientists thought it would be neat to have some international standards. So if you were buying a bag of flour in Berlin or Paris, you knew what you were getting. A team of researchers sat down and created an entirely new system of measurement. They called it a system for all time, for all people. In order for it to catch on, scientists created physical objects to represent each definition, including the metal cylinder now under lock and key in Paris. In the US, of course, I know we use pounds, not kilograms, but a pound, technically speaking, was defined as 0.45359,237 of Le Grand K. So you can remember that when you're weighing yourself in the morning. But today's problems require an incredible amount of precision. Whether or not we ever believed in things like equality is probably a topic for a different lecture. But in a world where everything is always changing, the scientists at the International Bureau of Weights and Measures decided that it didn't make sense for mass to be dependent on a physical object anymore. So as of May 20th, 2019, the kilogram is now defined by the Planck constant, which is a quantum physics equation that describes how the tiniest bits of matter release energy. A kilogram is now and forever set at, drumroll please, 6.6260715 times 10 to the negative 34th meter square meter kilograms per second. Like the speed of light, this equation is now considered a truth that will never change. This new definition doesn't impact cookie recipes, but for astronomers calculating how galaxies move, it could be a fundamental change. In 1983, for example, when the speed of light was redefined, no one was anticipating Google Maps or how dependent on them we would all become. But GPS wouldn't be possible without this definition of light speed. So the precision of the kilogram's new definition might similarly be important for unknown future discoveries. Quantum physician Max Planck himself predicted that the key to communicating with aliens, when of course we find them, might be measurements based on natural constants. A Martian might not understand Le Grand K, but any decent spacefaring civilization will probably measure the energy of a photon. To avoid chaos, in so many small ways, to keep the daily gears of our lives turning, we rely on these so-called universal truths. But finding fundamental constants can be really hard. We wake up with the idea that today will be like yesterday. Bosnian veteran Tarek Samara told me in Sarajevo, where I was reporting on Bosnia's post-war recovery. When the war ended, I realized nothing is certain. Today you have a state, a country, or money. Tomorrow you don't. Of course, we all experience lesser changes all the time. Your car breaks down, or Fred Meyers runs out of clementines because trucks can't deal with the winter roads, or the permafrost is melting, or oil reserves are dwindling, or you're wondering where you'll get your next job. The uncomfortable truth is that our day-to-day existence is a performance of impermanence. And at times, it can feel like an orchestra missing a conductor. Trying to reconcile changes in our lives, whether they're as extreme as wildfire or as small as a clogged sink, can be an endless aggravation. But from a scientific perspective, studying change opens doors to the universe. One of the perks of being a journalist is that I get to talk to people making big discoveries without doing any of the hard work. So tonight, I want to share a little bit of that wonder about killer caterpillars, duplicitous plants, the consciousness of death, and how change sits at the center of everything. Science, it turns out, isn't as good at reckoning with change as it would like to be. That's something Monica Gagliano, an evolutionary ecologist at the University of Sydney in Australia, knows well. Gagliano began her career investigating how environmental stress translated to the next generation in coral reef fish. I wanted to see what social stress does to fish, she explained. So for 4 months, she dove in the reef, monitoring numbered pairs, which sounds like pretty fun field work, and soon the fish grew accustomed to her. They were no longer alarmed by her presence. At the end of her field trial, she needed to collect the fish so she could take samples of their livers and brains, and she decided to go for one last dive in the water with them to say goodbye. It was just her diving, she says, with nothing strange to alert them. But they perceived something about her was different. She says, they told me with their behavior that something was not right. For Gagliano, it was a critical moment. She went back that afternoon to collect her samples and published her paper, but something had changed. Although she just received a new fellowship to continue her work on stress and aging in fish, with a lot of money attached, she says she had an ethical, moral career crisis. While working in her garden, wondering what she was going to do, she suddenly realized she could continue her research using plants. I'm always interested in the same question, she says, about why things work the way they do, and what that tells us about who they are, and in that, who I am. What does that tell us about being human? In a field that prefers to disentangle philosophical and practical questions, Gagliano's idea to determine if plants use sound to communicate was far-fetched. But through her marine biology work, she knew that animals make a lot of noise, which made her suspect that plants would evolve a response. Because I don't know anything about plants, I felt freer to ask questions, she says. I didn't have knowledge I'd already acquired to protect. Her initial experiments had exciting results. She found that the roots of garden peas were able to locate water inside of pipes by sensing acoustic vibrations, even in the absence of moisture, suggesting that plants use sound to perceive and respond to their environment. But this was just the beginning of her investigation into how complex plants could be. Language is often said to be one of the hallmarks of being human, Gagliano wrote in a paper published in Ecopsychology. Humans use language to make sense of everything that surrounds them, to share their perceptions with others, to reduce uncertainty about the world, and possibly to improve their capacity for survival. Gagliano's theory was that plants do too. Perhaps the most recognizable form of plant communication is movement. Over 450 species of plants change color, position, or shape in order to advertise their goods. Less obviously, many plants also use chemicals to convey meaning. Michael Kessler, a researcher at the Max Planck Institute for Chemical Ecology, found that some wildflowers discourage scavengers by adding tiny amounts of nicotine to their bouquet and remove trace chemicals to encourage other pollinators. It's now well established that plants use chemical signals to warn each other of insect invasions, allowing unaffected plants to produce protective compounds before they start getting eaten. The symbolic use of language is what gives humans the ability to lie. So, too, do orchids trick wasps by releasing chemicals similar to other plants' distress signals, beckoning the predatory wasps to feed on non-existent caterpillars. Other plants mimic pheromones of the honeybees that different types of wasps prey on. Duplicity, it seems, is found even in the vegetative world. In this context, the idea that plants might perceive noise is maybe not such a long shot. When you look into strange things with no expectation, you might be lucky enough to find what's happening, Gagliano says. But we live in a world where what's happening is becoming rather strange. Vanquished diseases are spreading, conspiracy theories are flourishing, deepfake videos are shaking faith in the evidence of our eyes and ears. We're living in a time where tremendous skepticism is counterbalanced by a hunger for answers, and we don't always agree with where others find them. Many more traditional plant researchers have quibbled over Gagliano's use of the word consciousness in relation to plants, and her findings have been controversial, although more over her language than her methodology. Spirituality and science have long made uncomfortable bedfellows. But it turns out something as simple as a slime mold, we're talking single-celled amoebae, can remember, make decisions, and anticipate change, all without a brain. In fact, in one awesome experiment at Harvard, slime mold was more efficient than grad students in getting out of a maze. True story. Or take a comparatively advanced organism like the mushroom Amaryllia, which has the kind of longevity Silicon Valley tech moguls are pouring billions of dollars into researching. This mushroom's been growing in Oregon since before the advent of agriculture. Of course, that's a blip compared to aspens. An aspen grove in Utah, which migrated south during the last ice age and is now creeping slowly north again, is thought to be over 80,000 years old. The so-called quaking the species is known for is in fact an advanced manipulation of the tree's environment. In experiments, trembling leaves have had about 27% less insect damage. In other words, we still have so much to learn. Maybe we should tremble too. In some ways, that's what my reporting has taught me. Science, at its best, is the practice of marveling at the world. But there are times when uncertainty makes wonder a difficult pursuit. I'm a freelance magazine journalist, which means that not only am I trying to make a career in an industry that's racing itself to the bottom, I'm aiming for the most obsolete part of the market. I travel quite a bit as a result of my work, covering the intersection of environmental and human health. And the last few years have been rough on both science and journalism, which makes it a tough beat. This winter, in between projects, I landed in Athens, Greece, a location whose perks included being able to buy dinner for €1.50, which makes uncertainty just a little bit easier. I wrote pitches and begged for my emails to be answered. It's how I spend a lot of my time. It was February, and the streets were lined with orange trees, an abundance that mostly ended up rotting on the sidewalk. I was a little embarrassed to become a regular at the falafel stand on the corner below the tiny apartment that I rented, but it was always the same men, taking money and making food, joking across languages. My favorite, Mohammed, had a smile that started in his eyes. He was from Syria, and he always made sure to tuck in extra fries for me. Over the refugees sleeping on the streets, dogwood trees blossomed. I take my falafel to the park, where ancient ruins poked out of olive groves that the homeless used as bathrooms. Athens, it turns out, is a pretty good place to be wondering about change. Here in Fairbanks, I know it might be difficult to visualize 3 million people living on top of each other in stacks. From the heights of the Acropolis, the white sun-baked streets looked like a hive of activity. You could see the cyclical nature of civilization in the rise and the fall of its streets. There are so many ways to hunger. And all over this park's dusty paths, I would see caterpillars, marching in straight lines, one after another in a furry kind of conga line. And I was always trying not to step on them. So imagine my shock when I learned that they were dangerous. Processionary caterpillars are actually considered a pestilence across Europe, routinely killing dogs and plaguing people. It's because their tiny hairs sting, causing severe rashes and lung problems when inhaled. The adult moths lay eggs near the tops of pine trees, where larvae live in silken nests, and they emerge to the ground in the parade that they're known for when the weather warms. In 1916, a French scientist conducted a study on processionary caterpillars, setting them up so they would march head to tail around the rim of a flower pot. Jean-Henri Fabre reported that the insects continued their fruitless slog for over a week. Since then, the study's been held up as a metaphor for blindly following a leader or confusing activity with accomplishment. Fabre thought that the caterpillars were doomed to circles, if that's where destiny or interfering scientists led them. But a more recent study puts a point on the moral. Perhaps the caterpillars were, in fact, trapped by the narrow rim of Fabre's pot, unable to walk down the slope of its walls. In 2008, scientists repeated the experiment, placing groups of the caterpillars on a flat table and surrounding them with a glass ring. Like in Favre's study, the insects move to the edge, one behind another. They begin to circle, eventually forming a well-established trail, and then the scientists remove the glass. Without constraints, the endless circle continued for an average of 2 minutes. Then the caterpillars course corrected and proceeded off in a straight line. Some theorists hold that learning requires change. One definition of knowledge acquisition is an internal alteration. In other words, knowledge isn't a stationary endpoint, it's a process. In these terms, science isn't meant to be certain. It's a method for observing and understanding the world as we currently know it. In fact, not only is it not certain, it's when we stop asking questions about previous assumptions that we run into trouble. Here in Alaska, it probably won't strike any of you as a ground-shaking revelation that the world around us is interconnected. People have thrived here for thousands of years by understanding that interdependence intimately. But it's not until recently that Western epidemiologists have focused on how the health of animals, humans, and the environment are intertwined. This kind of multidisciplinary research is often called One Health, and it's a surprisingly new approach. In 2017, I had the chance to shadow such a project in the Free State of South Africa, a region of dry plains and sprawling farms. It looks like Montana or Nebraska, or anywhere else where the sky is bigger than the land. One morning out in the high veld, red dust was rising up in rooster tails behind our caravan as we approached Cobus Steenkamp's farm in the cold dawn. Steenkamp woke up here one morning to find something strange happening to his sheep. You could see there's blood at their backs, he recalled. All his pregnant ewes were losing their lambs. It was every farmer's nightmare. His flock had been infected by Rift Valley fever, a mosquito-borne virus that causes abortion and death in animals and can be transmitted to humans. Within days, dozens of people had also been infected. Most displayed only mild flu-like symptoms, but in some cases, the illness escalated into a severe hemorrhagic fever, akin to Ebola. Rift Valley fever was weaponized by both the US and the USSR during the Cold War. Today, its spread is feared by farmers and the National Security Agency alike. So on Steenkamp's farm and hundreds of others, this team of scientists were studying vegetation, precipitation, and taking blood samples from livestock, wildlife, and farm workers. Zoonotic diseases, infectious illnesses like Rift and Zika that began in animal populations and jumped to humans are the biggest risk for epidemics. They've been responsible for some of history's worst diseases, including bubonic plague and Ebola. The problem is that public health researchers still don't know how to effectively predict outbreaks. Meanwhile, the threat of emerging diseases is expanding, and in unforeseen ways. Global warming and extreme weather patterns are changing who gets sick, and from what. As climate change introduces species to one another for the first time, as ocean currents warm and animal migration patterns change, diseases are spreading in an unpredictable manner. Amid this limbo, the scientists in South Africa were attempting to develop a model that could predict outbreaks of Rift Valley fever before they happened. Some of the samples were easier to collect than others. One morning, we pulled up to a private game reserve near McCullough National Park to chase down kudu, a type of African antelope. A helicopter pilot with a dart gun arrived to lend a hand, and soon we were in truck beds, bouncing over the dry grass, a cloud of dust marking our progress toward the herd. Beyond the front tires, the animals swerved, gleaming. The stillness when one was tranquilized was a little shocking. The scientists worked quickly, sliding around a maze of arms and legs with syringes and vials. The kudu would only be under for a matter of minutes. After the animals recovered, the researchers packed up their blood samples and began their decontamination procedures, scrubbing dust off their boots. Nearby, a caged lion lounged in a puddle of sunshine, awaiting the delivery of his next meal. He yawned at the stream of passing cars. Once, the bushveld stretched wild over half of the country, but today there are few places where wild game still wanders free. The world has already changed, even if we don't yet know the consequences. If you've never heard about Rift before, you're not alone. Here in the US, we don't often talk about diseases like Rift, or chikungunya, or tick-borne encephalitis, because they're not here yet. But take malaria, for instance. We think of it as a tropical disease now, but in fact, until the 19th century, most populated regions in the United States suffered from malaria epidemics. And it had a big impact. One study looking at Union Army recruits in the 1850s found that those who'd grown up in one of the many counties with malaria were on average 1.1 inches shorter at enlistment. Of course, Michigan is no longer a malarial swamp. We are capable, sometimes for better, sometimes for worse, of tremendous adaptation. When the Tennessee Valley Authority started building hydropower projects in 1933, over 30% of the state had malaria. By controlling water levels and by spraying DDT inside millions of homes, transmission of new cases was eliminated by 1949. The effort actually became the birth of the Center for Disease Control. But DDT, it turns out, kills more than mosquitoes. So often we've created change without understanding the implications. This week, California is seeing record-breaking fires. But wildfires in the West have been breaking records for the last 2 years. The past can inform the future, but previously rare events are now happening more frequently. We don't know, it turns out, what we don't know. The fundamental question is how or if we're able to adjust to a world that's in a constant state of flux. We deal with the uncertainty that change brings in different ways. Stocking up on food before a storm, burying gold bars in the backyard, or placing faith in religion. But one of the biggest challenges I see for science, and unfortunately for facts in general, is that it's easier to find problems than solutions. But here too, we can perhaps take inspiration from the world around us. It turns out there's some pretty fantastical caterpillars around here too. The Arctic woolly bear moth, not pictured here, is found in northern Canada. It's pretty small, nondescript. It emerges from its egg in the fall and overwinters as a caterpillar, where it literally freezes solid. First its heart stops beating, then its gut freezes, then its blood, followed by the rest of its body. It survives by producing a chiroprotectorant in its tissues. In the spring, it thaws. Over its lifetime, it will freeze and thaw 7 times. Like the rise and fall of empires, change can breed fragility, but incredible resilience too. We are, in fact, built from this tension. In the late 1920s, physiologist Walter Cannon was studying traumatic shock in troops returning home from the First World War when he coined the term homeostasis. Now considered a fundamental part of modern medicine, this is the idea that a cell or a body has a tendency toward a stable equilibrium. But homeostasis isn't a constant, unchanging state. It's a description of a dynamic process. When you leave your heated house in December in Fairbanks into -40, while the external temperature changes as much as 110 degrees, your internal core temperature remains the same. And humans are actually pretty bad at thermoregulation. An Arctic fox, by changing its fur depth as much as 200%, has a seasonally constant heat loss, despite the winter extremes it endures. Cannon argued this ability to adapt to a changing world was the most important element of life. Homeostasis does not occur by chance, but is the result of organized self-government, he wrote. Our hearts pump, our blood beats, we breathe in, we breathe out. And the point of all of these moving systems is to maintain stasis. Writ large, these cycles are what make up an ecosystem. These systems are not built to withstand change. They are the sum of their forever shifting parts. In fact, the incredible feedback loops that make up the fabric of our lives are so continual that we don't notice them until they stop working. Sam Parnia is the Director of Research into Cardiopulmonary Resuscitation at the NYU Langone Medical Center, and his British accent makes him sound oddly upbeat when he talks about death. The criteria we use all over the world to declare death is no heartbeat, no breathing, no brain activity, he says. During a cardiac arrest, reflexes controlled by the brainstem, like your breathing, stop when your heart stops. Your pupils, for example, won't dilate. Due to this lack of brain function, for the lucky people who get medical treatment in time to be resuscitated, scientists wouldn't expect them to remember what happened. You might have some memories of before your heart stopped or after it comes back online, but there should be no memories formed during the time your heart's not beating. But after a study in 15 hospitals in the UK, the US, and Australia on over 2,000 people, Parnia is reshaping what we think we know about death. The brain typically shuts down within 20 to 30 seconds after the heart stops. But Parnia says, paradoxically, 40% of those who survived a cardiac arrest were aware during the time they were clinically dead. There are conscious thought processes occurring where data says the brain doesn't function. One patient in the study described floating up to a corner of the room where he watched medical staff defibrillate his chest, with details of his vision checking out with the staff. By the patient's description, Parnia thinks he might have seen things that happened a full 3 minutes after his heart stopped. Contrary to perception, death isn't a specific moment, but a potentially reversible process that occurs after the heart, lungs, and brain cease functioning, Parnia says. And at this point, lest you think he might be a little cuckoo, the study was published at a peer-reviewed journal called Resuscitation Journal, and he's well respected in the field. But this does raise some big, interesting questions. You and I and everyone we know interact through our self, our soul, whatever you want to call it, the thing that makes us who we are. The Greeks called it the psyche. Today, we're more likely to call it consciousness. Parnia says, we in science have assumed that our conscious is produced from brain cell activity. But when you look at the science literature objectively, we have no data to demonstrate how the brain can produce thoughts. An alternative theory is that consciousness may be a separate, undiscovered process, one that moderates your brain rather than being produced by it. Parnia suggests that it might just be that we don't have the tools to measure it yet. If we believe that consciousness is simply the byproduct of brain activity, he argues, then we can't hold people accountable for their actions. There'd be no real self. Society would fall apart if we believed that, he says. The reality is that we have free will, and our actions are not determined. But Parnia is unembarrassed by the philosophical implications of his research. There's nothing unscientific about the study of the human conscious, he says. It doesn't make sense for that to be relegated only to religion. Everything we now know about astronomy or medicine used to be the territory of faith. And Parnia foresees a future where everything that's been considered religious is studied objectively. There will always be things we don't understand, he says. Thousands of years from now, who knows what science will be doing? But I'm sure that even then, there will be things that have not been discovered. There's always a need for new tools. If you adhere to belief systems and are never willing to look at new evidence, you can't change, he says. It's that fundamental. As adults, we can become too settled, or too busy, or too panicked to truly wonder at what we don't know. We can lose our sense of awe. That sense of wonder is a side of change that often gets lost in our pressing focus on what's at risk. But sometimes when I talk to scientists like Parnia, I feel like a 10-year-old, full of dumb questions, like, what do you mean we don't know where thoughts come from? Or, how do woodpeckers not get concussions? Or, what does space smell like? Or, how do bugs breathe? I have actually asked scientists all of those questions within the last year. Insects, in case you're now wondering, don't have lungs. They draw in oxygen through holes in their bodies called spiracles, pumping it through a system of increasingly tiny tubes that deliver oxygen to their tissues. Because spiracles can open and close as needed, many insects can live a long time without breathing. The word spiracles, like the word spirit, is derived from the Latin spiritus, meaning breath. The exchange of gas in an insect is the physical act of spirituality. Gagliano told me that the main difference she found after changing her research focus is that she used to live in a world full of objects. Now I live in a world of subjects, she said, and so I am never alone. And it's this sense of possibility that I was thinking about while driving up to Fairbanks this summer, through the Canadian Rockies. Winding through glacial river valleys, the road twists along clear water, evergreens as far as the eye could see. As the sun sank behind the mountains, I spotted a little black bear cub, somehow on the wrong side of the wildlife fence, scurrying along the shoulder of the highway. Our impact, it turns out, can't be enclosed. In the morning, as I topped the next peak, the peaks rose in rusted glory, red as New England fall. Thanks to climate change making winters milder, Over the last few years, bark beetles have infested over half of the pine trees in Jasper National Park, killing hundreds of thousands of acres. The redden forests line the roads, standing like prophets, their prognosis unchangeable, but providing life a little more, a little more. What looks like devastation is also opportunity. The beetle die-off will increase the forest diversity. It will decay into a totally different ecosystem. The dense green pines morphing into savanna, dotted with beech and birch. The Rocky Mountains will continue their cycle of erosion and soil generation. Watching the sun blaze over the dying, I was reminded of a poem by W.S. Merwin that I've always loved. Separation, he writes, "Your absence has gone through me like thread through a needle. Everything I do is stitched with its color." That's the thing about the geophysical world, Matthew Sturm told me when I arrived in Fairbanks. It's going to survive. He's researched snow here for 40 years. It will snow long after humans are gone, he says, and the snowflakes will be absolutely pristine and gorgeous. He told me, you know, we were always going to be a fleeting species. We're like a shooting star. Humans are self-aware of their place in the universe, and that's amazing. And perhaps it was always going to be a short run. We've only got less than 1 million years under our belt, out of 13 billion. What made us think that we're going to get much more? He added, of course I'd like to see more. I'd like to see grandkids have a good time. It's cold comfort for grandkids. But the cosmos goes on without me, and it's still a magnificent thing. That marvel, 50 years ago, that's what got us to the moon. Now it looks like Mars just might be next. Here on Earth, science gives us the tools to ask important questions. What impact are we having? Knowledge can be a heavy weight to bear, but maybe that's all the comfort we can ask for.